right. So now that we've worked through our objects a little bit, it's a little bit later in the day, but we are going to create our own kinds of object prototypes. So we've got like the object class, we've got the array prototype. And these are all like objects and prototypes have a very odd relationship. It's very difficult to keep the two apart. I'm not going to get too much into that because you classes and prototypes especially are very difficult to keep apart, and to try and delineate all of that stuff would take a great deal of time, and so I'm going to show you what they are, and then going forward we'll see how much we actually use either of them, because classes are not a great idea in JavaScript. It's something that is extraordinarily common in languages like Java, C++, Go. Those are all what we call object-oriented languages, where the primary way, actually those ones all enforce it. You have to write an object-oriented code. We'll talk about what that means a bit down the road as well. But JavaScript, I personally believe that functional programming is a better approach to JavaScript. It's a lot safer, a lot more straightforward, and even a lot of people who program in object-oriented languages often over time end up writing in a very functional style, even though what they're writing really is in an object-oriented language. But the way that they're processing and handling their functions and such is a functional style. Anyways, we'll explain what that means down the road a little bit. Promise we'll get into that. I talk about it a lot because I'm passionate about it, and it makes code better, and makes you make code better. But we're gonna look at some prototypes here. So we've got, I think it's this way. Yes, cool. Last thing we did was we logged math, just the whole thing, see what it was. But what we're going to do now, so we're going to create our own object prototype here. And my computer's lagging a little bit, but that's okay. All right, excellent. So we're going to create our own object prototypes. And so this was something that was new to ES5. Again, the ES is for ECMAScript, and there's a variety of versions of that. Most of the time we're going to be writing in ES6. ES5 is a previous version, so obviously we'll get that as like a grandfather into the language kind of a thing. But we are going to, we're going to write a function, but keep in mind that usually when we write functions, we start out with a lowercase letter for the first letter of the for the function. In this case, we're going to use a capital letter, which is a little bit odd. Pass some stuff in, and we're going to do some interesting thing. We'll just see it. So we're going to do function. We're going to do car, and we're going to pass in make, model, and year. Okay, so that's all seems mostly normal, except for the fact that car has a capital letter. So that's our first question. Why is it that way? Well, and then we're going to put some stuff together here, and they're going to be constants. And the way that we do this, it looks a little bit odd. I'll explain it kind of as we go. But we're going to use this dot make. It should be in here somewhere. Yep, make. We're going to set this equal to make. You'll notice that automatically things are changing. So it suddenly has realized that we're creating a prototype. And then we're going to do this dot model equals model, and then this dot year equals year. So far this is all fine. Now it's mad at us about something. What is it mad about? It's not actually mad, it's just taking it. Okay. And so what we've got here is when we create a car, similar to like when we like call a function, when we create a car, our so this is like the idea of a car, right? Similarly, when we create a function, our function operates, and but when we design the function, it doesn't actually happen yet. It's the idea of the function. It's not the actual thing yet. Nothing's happened. You have to like turn the engine on to make our function run, right? And in this case, our car, this is the blueprint of a car. And so this is, we can say like a blueprint. There, okay? So this is the blueprint of the car. And a car not only has like attributes about it, like the make, model, and the year of the car, or like how many doors it has, or whatever. there's also things that the car does. There's like processes that it's capable of doing. And so what I want you to think about is that object prototypes have attributes and processes, right? There's these two parts of it. So we're going to write one of those processes, and it's going to look like a function. So we're just going to put a comment in here. A function inside a prototype is called a method. And we've seen methods before, right? Where we're using dot notation, like that is a method, and you see it right there, method. Okay, so we've got the object prototype, and then the values method that does something. Okay, so we're gonna actually write one of those methods. We can use it as dot notation down the road, which is cool. And so we can do, we're gonna use this dot print info equals function, and we're gonna pass in how many wheels it has and default to 0. And then we're going to pass in color. Actually, I'm not sure that should work, but that's fine. We're going to default color to blue just so that it doesn't freak out. And then we're going to do this, and just like a normal function, we're going to console.log, and we're going to use the tick marks. So those are not normal apostrophes. Look closely. Those are tick marks. I'm going to say this is a this.year. We'll explain what this means in a second. Year, and then we're going to do a space. We're going to pass in this dot make space $, this dot model, and it has, and we're going to put in this dot wheels, and the color is this dot color. And I'm going to put this on a new line here because I don't want to look at that. It's kind of scary looking. There we go. Now it's readable. Hooray. And actually, let's change our default for wheels to 4. That seems like a pretty reasonable number of wheels for a car to default to. Cool. So now we have that. So this is a method we can use here. Now we have to actually create the car. So this is all fine. This is just a theoretical car, right? We've imagined a car now that has some attributes and it has some processes. Okay. And we can write more of these. This thing we'll talk about in just 1 second. So if you're confused about this, I'll explain that momentarily. But we're gonna say let my car equals, and this is how you create a new prototype, right? We've seen this before. We've seen it with date on the last document, and we've seen it with I think earlier with we had new something or other earlier today. I don't remember where it was, and I don't care that much. There we go. We created a new one of these. But that new thing is for prototypes of things. And so we're going to use that new word again, and we're going to say car, and it immediately knows that we're talking about a car. And we're going to do a Honda. We're going to pass in CRV and 2019. Okay, great. So now we've actually created a car, and the make ends up being Honda. Gets passed here and assigned to this. So this dot make is make. CRV is the model, and it's a 2019. All great. Now, please note that each of these values gets moved over here, and this dot make ends up being this thing is actually like an actual attribute of the car. So you can pass things in there that don't end up being attributes of the vehicle or of the thing that you're making. But that also would mean that if I don't use this here, it might have a hard time figuring out where the stuff is coming from. So using this is going to be really useful for moving things from place to place. Like if I had another function called this dot do something, and I just said console.log year, that won't actually work because it's not going to know how to get that information, because this is only getting passed to here. These are not getting passed into this part of it. And so that's not a good way to write code, and that's not how we do that. So putting it to this is great. And then if I didn't have the word this here, I want you to think of the word this kind of like it's ultimately what's really happening is the word this is talking about the whole thing, right? So it's just self-referential. It's saying, oh, anything inside of here, I want to be able to access. But as far as how you practically would use it, right, what I want you to think about is this as, I don't know if you've ever put like a picture or a homework assignment or whatever on like Google Drive, put it on the cloud, right? So I have, let's say I've got a document on my phone and I want to move it to my laptop, right? I could email it to myself, but even with that, I'm putting it on the internet and then downloading it someplace else. And the this keyword, in this case over here, this takes make and puts it into this. It puts it into the whole prototype, the whole object. When I do it down here, like this, there, I have to find other words than this. It's very annoying. But when I put it here, it actually is pulling it back out of that whole context and utilizing it here. So the way that that's working is it's as if I'm putting feed make into my computer. My computer uploads it to this, the cloud, and then later I say, oh, I want to use that document. I want to use make, and I download it with this here, and now I can use it right there. So that's basically what's going on there. When you end up writing objects and prototypes in classes, really prototypes in classes, but when you end up doing that, you're going to end up, that's the way to approach it. You're going to have some snags. I'm sure you'll go, oh, I didn't quite turn out the way I wanted it to. Like this thing is one of the trickier parts of this. And we'll see more examples of this. We'll use this more. So now we've got the car, but nothing happens at this point. And this function has not been run. This right here has not been run. So let's actually run that. So I'm going to do console.log. And you might think that we would do car here, but that's actually not correct. What we want to do is take my car. So we've actually created one of these things and saved the actual existing thing to my car. Again, this up here from line 231 to 242, this is all the idea of the car. The actual thing that we've made now is a Honda CR-V and saved it to the value my car, right? Console.log my car, and when I do dot, we should see a variety of things show up, right? So I could print this model or year, but what I want to end up doing is actually using the print info method, and I'm going to run that, and I'm going to pass in 4 wheels, and I'm going to change the color to gray. And we should see, whoops, assuming I don't write anything real weird, we should see that show up over here. Okay, cool. So this is a 2019 Honda CR-V, and it has undefined, and the color is undefined. And we have returned undefined. So that didn't quite go the way that we would have thought. Let's add another line in here, and we're going to return. We'll do return 1 for a success code there. And I don't think we actually, so this one, so check this out. Because wheels is getting passed directly into this function, we actually don't need this here. We're not actually pulling it down from the cloud. It's completely localized. So we can just do that, see how that turns up. It's happy now. I was wondering why those were still dark, but that's all good. And now when I run this again, this is a 2019 CR-V. It has, I probably should have said the number of wheels. Color is gray. And I'm a little bit surprised that actually worked out that way. I think it's the tick marks. Tick marks can get weird with new lines. But that works out fine too. That doesn't bother me. So there you go. So that's a little bit about how to make our own prototype. So we are now creating the idea of the car. This is like a data type that we could theoretically reuse. So it's a little bit odd to do this with a car because I think we're about to use this again for, we're going to use it for humans now. But the difference between the prototypes and the classes we're about to use is a prototype is meant to be its own data type, right? Like we're able to create our own, like an object is a data type, an array is a data type. You know, like those kinds of things. And so now we're able to create our own versions of those. And if I were to console.log in the same way that earlier we did math, we logged out math, we should be able to come back here and we should see all of the stuff that's in here. Obviously it's a little bit different. Theirs is a little more full. But there we go. So you can actually see that information about our car. And I don't think it will change too much if I will. It probably actually will, but it's not what I'm trying to do. Yeah, undefined. Didn't return anything because it's not a function. It's a prototype. It's a different thing. All right, great. So moving on. That's about enough theory around prototypes. Let's do classes. What's my time at? 15 minutes. And yeah. All right, we'll do classes real quick. Again, I don't object-oriented programming. I understand it. It's just it tends to be buggy, which you'll see as soon as you try and write your own. But JS classes. But this is still good stuff, and there are still a lot of people out there who use object-oriented programming quite a bit. It's an important part of like real-world coding because essentially, when I talk about functional programming, here, theory time. When I talk about functional programming or object-oriented programming, these are both just different approaches to the same problem, right? What this is imagine, I mean, like, if you just look at our documents here, right? Like, this is a lot of code, and trying to imagine like writing an actual application that had this many functions and attributes to like a full-on website, right? Like, think of visiting Facebook, right? Like, there's so many pieces of data moving on and so many things to keep track of, and JavaScript's doing all of that legwork. And again, we'll see that later in things like React and some of our API stuff with JavaScript that we're going to do. But it's a lot to keep track of. It's really hard to keep organized. We're at line 250. Our first document had 400 lines or something like that. Yeah, 337. That's a lot to keep track of, right? And we're not even doing anything that ornate. So you imagine something like Facebook is going to be thousands and thousands of lines of code. And so what we're approaching is this place where we go, we've got a lot of things happening. How do we organize it, right? What's a good way to keep it from turning into just absolute chaos? Because especially if you write an app and the app works and you have to update something and you have to parse through several thousand lines of code, you don't know where the problem is at all or what you called it or anything. It's a lot easier to organize it into some sort of structure. And object-oriented programming came about as one of the not the earliest, but an earlier approach to the solution. C++ uses it, like I said. Java uses it. C++ is older. But they both use this kind of approach to solving their problems. And what this is you basically have each object or class, object-oriented programming. JavaScript uses objects in a very different way than other people do, but that's fine. That's part of why it's a little confusing to learn, especially if you come from other backgrounds. Or even if you come from no background, it still can be a little bit like, why did you call it that? And I don't know, but it bugs me too, so I'm suffering with you. I also have to explain it, so by using words other than this and object. But anyways, point is, an object or a class, in the way that we're about to learn, a class is going to be a individual thing. It's going to have, again, attributes and processes in the same thing. But each one is meant to be like a piece. It's like one aspect of our code, right? So like, let's say you have a website. You're going to have like a login object. You're going to have a log out object. You're going to have a homepage object. You're going to have, and all those kinds of things, right? And there's good and bad ways of doing this. For a website, we'll look at that obviously later, but for right now, that's basically what an object is. And you can use different objects to do different processes, handle different data, interact with the rest of our code in different ways. And it's just a way to kind of break things down. There's 4 main attributes of coding this way. And I'm going to actually type those out here and talk about what they are. So we're going to have encapsulation, and this is this idea of breaking it into pieces, right? That's kind of the main idea there. We're just going to say, I'm going to take like each part of my website is going to have one object assigned to it. It's going to have its data that goes with it and the processes that happen in there. Within classes, that data is usually called state. We'll see that especially with React, but we'll get there when we get there. That's encapsulation. It's kind of broken down into its own thing. We're going to see, so breaking into pieces. We're going to have abstraction, which just means that like I can call car like this, and I don't need to know everything about it, right? Or I can use math, right? I can console.log math, wherever I did that at. Yeah, console.log math. I don't need to know everything about math to use math, right? I don't like we've used math attributes like .floor. We've never even seen that function, right? It exists out there, obviously. And when we logged it to the console, maybe you looked at that, but you don't have to know everything that happens there to use it, right? And that's an abstraction. And we've seen this before as well, right? Like we do something really hard and we say, actually, there's a really better tool to use that. So this is like, we don't have to know the details. And then next we're going to have polymorphism, which is a tricky one, to be honest. But we're going to see how it works as well. This basically is saying that like code will work any in any scenario that works with the kind of prototype interface we're looking at. We'll see what that looks like, but essentially as long as something's expecting, like say, we'll take this like as a string, for example, right? As long as your code is expecting a string, any string should be able to work there, right? That's kind of the idea there. And the last one is inheritance. And that is when we do inheritance. It's not all objects use inheritance, but we can extend attributes from one object to another. All right, Brandon, what on earth does that mean? Yes, I'm well aware that that is probably pretty vague. You're probably pulling your hair out, and that's fine. We're going to look at some examples and see how this works in real life. So we're going to do something very similar to what we just did with our prototype. However, when we're making classes, so we're going to do class human. The human itself, the class itself does not take any attribute. It doesn't bring anything in. So we're going to do instead, we're going to use a function called constructor. This is a special function for classes. Classes only use them. We're going to say name, age, and gender. And then we're going to say this dot age. It's the same idea. It's the same language. This dot name equals name, and this dot gender equals gender. Now, this is going to be something you're actually probably going to use in the wild on a somewhat vaguely regular basis. Making your own object prototypes, like creating your own data types, might be something you use if you use a lot of TypeScript, but if you're using a lot of JavaScript, you probably won't. So if you're a little bit fuzzy on this stuff, don't worry about it too much. This is going to be more of our focus today. So we've got that. We've used the constructor. And again, so what happens is when we call class human, something has to happen to make the thing, right? We've got the blueprint here, but this function is just saying, hey, when you make a new human, this is the function that's going to occur, is going to be right here, okay? And then we can have a print info, and note that this time we are not utilizing this for print info, okay? Because the class operates just a little bit different than a prototype. But what we're going to do is we're going to return, and we're going to use the tick marks. Name is going to be, and it's back, this dot name. And that's again because it's understood that each of these things are attributes of human here. I think the classes are a slightly newer idea than the ES5 prototypes. So we've got this dot name. We're gonna do a new this backslash n writes a new line. I think I've been over that, but maybe not. I'm gonna say age, and this will be this dot age, and then gender. This dot gender. Cool. And great. So now we're going to create an instance of our new class. Create an instance of our new class. So we're going to say let Wilma equals new. So we still have to use the new keyword. New human. I'm going to pass in Wilma, and Wilma will be 25 and female. Great. And so now we should be able to console.log Wilma.printinfo. And of course, we could have probably just put a console log in here, but once we're in classes, it's really not wise to not return things. Because again, we're going to be moving data around from place to place. And so the console log now is going to be logging the returned value rather than trying to log it while it's inside of here. And that's a really quick example. Actually, forget it. Let's do this. I will show you why it's a bad idea. So console.log. I'm going to put this whole string in here. Great. And we're going to see why this is problematic, because it will still print, but now we're going to have that undefined at the end of the day again. And that's not desirable. That's not what we wanted to do. And we're not able to use any of this information. Now, obviously because we can't access the string anymore. We can't do string methods on this stuff. None of that will happen. If I was to do like .length, that shouldn't work. Yeah. Okay. Because it's undefined, and now you're trying to read the length of something that is undefined. So we've got a type error because undefined things have no length. However, if instead we return this, now we have a little bit more control over it, and it has a length of 36. It's 36 characters long, right? And so that's why I keep harping on you, and you should be a little scared of data types, and you should be like paying close attention to those, because when those data types go wrong, they really go wrong. It can be extremely annoying to try and debug data type problems. And so I'm trying to help you, trying to keep you from falling into that pit that I have fallen into frequently. So now we've got that. And the last thing we're going to do here is we're going to look at some inheritance. So far, encapsulation, right? Like breaking to pieces, like we've got... like this is just one human. This could be part of like a group of humans, right? Like I could make like 3 or 4 more humans, right? Let Gerald equal new human. His name is Gerald. He's about 73 and he's male, right? We can make a whole bunch of humans as different parts of something. We could create a class that is like a adult learners class, right? Like we could have a students class, we could have like a teachers class, we could do all these different things that are different aspects of, say, a classroom of adult learners. And so that would be something we could do there. And then they could have we could add methods if we wanted to, as many as we want to. We can have all these different functions and stuff that happen inside of there as processes that humans do. Marvelous. So that's encapsulation. Abstraction is you can just make a new human with just this information, right? You don't need to necessarily know what all of this stuff does. Obviously, this is a very small class, but you can imagine some of these classes have like 30 to 40 different of these methods involved. Cool. So that's abstraction. Polymorphism means that anywhere that's expecting a human, it will end up playing out. So that's cool. And we're going to see how polymorphism works with inheritance here in just 1 second. So now we're going to see JS inheritance using classes. Great. So now we're going to make a new class. This class is going to be class baby. Okay. Now, instead of running right into the body of our class, we're actually going to use this word called extends, which is really rad because human. That's nice. That's nice. And what happens here is we actually automatically import all of these attributes, right? And any methods involved as well. And we'll see this in just a second. We still have to have a constructor. So we get constructor. We're going to pass in name, age, gender, and walking, which will be a Boolean for whether or not the baby is walking yet. We're going to use super, and super is going to pull back. Look at this. It actually automatically tells us like, hey, these are all of our attributes and data types associated with them. Obviously, all of them are any because we did not specify them, because JavaScript doesn't really do that. TypeScript will do that. JavaScript lets you get away with it anyways, even if you don't follow directions, as we've said. So super, we're going to pass in name, age, and gender, and that works out fine. But this means that now our entire baby class has a name, age, and a gender. And it's that easy. Like I don't have to rewrite all of this stuff, and the constructor will just automatically pull that down and give us access to it. And then this dot walking equals walking. Okay, so that's great. That's what we wanted to do. And obviously, this is again another thing that makes a little more sense on a larger grouping, but on a small scale, at least we can see kind of some of what's going on here, right? Now we're gonna make a function is baby walking, and we're gonna obviously expect a Boolean. So if this dot walking equals true, then we will return, not log. I've been doing a lot of logging because I've been teaching. And do baby is walking. And then we'll do else. We do return baby ain't walking yet. That would be not my line of code, but I love it. All right, cool. So now we're going to actually instantiate this, and this gets where things stay cool and stay interesting. So we're going to say let Johnny, oops, let me see what we're going to do here. Create instantiated. And again, I think we talked about how like instantiating, calling, all these words all basically mean the same thing. Values for baby. I'm going to say let Johnny equals new baby, and we're passing Johnny. He's 1. He's male, and it is true. Johnny is walking at the age of 1. Incredible baby. Console.log Johnny, and then we have some attributes. We could actually just print out like Johnny's age, right? And that should spit out 1 at the end of the day here. Or we could also do, you know, console.log is baby walking, and run that, and that should say baby is walking since we fed it true. Is baby walking is not defined. I could have sworn that I did, but did I spell something wrong? Don't believe so. Oh, I need to. There we go. That makes more sense. VS Code tripping me up. VS Code's like, oh, I remember that. That's in the environment. It's not actually in the environment. It just thinks it is. All right, cool. Now this is the one that's really cool, right? Because nowhere in here is the print info function, right? We never gave it. We never passed it along. We never did any of that stuff. And so what I can still do, because of inheritance, Johnny dot print info. And I can actually do that, and it will actually spit out some information about Johnny. And that's cool. And that actually means that we end up theoretically, writing less code because we're reusing things. We can say, oh, you know what? I've already got a human class. I'll just apply this to something else. Because baby class is anticipating and expecting and will work with that prototype or interface for polymorphism. That works out. We don't have to know all the stuff that's happening. We can create a human without having to even know what the print info thing is. And it's broken into pieces, right? Like we can say this is a baby class and a human class. And that is how those 4 pillars of object-oriented programming end up playing out. So again, we're going to have some exercises. Those will be on Google Classroom for how to work through these things if you're taking the full course. And to play around with these. One of my favorite things, this is just for any language that I'm learning, especially if it's object-oriented, but really any language I'm learning, is to make a parking garage that will say, oh, hi, welcome to the parking garage. What would you like to do? And then you give it some input and it does something, and then you can say, wow, great, thanks. What else can we do here? Et cetera, et cetera. Like you want to pay, you want to have a spot, keep track of how many spots you have. Anyways, but that's a really good exercise for object-oriented programming if you want to do that on your own time, if you're not taking the full course. If you are taking the full course, then you have to do that assignment. So anyways, I'm at 33 minutes. I've talked forever, and I'm tired, and I'm going to move on to the next lecture. I'll see you there.